Apart from simple series and parallel connection, we can have some other arrangements of elements. So let's say we have three elements, three resistive elements, and they are connected like this, or maybe they are connected like this. So when we have something like this kind of arrangement is called delta, because it looks like delta, this one. So it's called delta arrangement, while this one looks like a Y, these three. So it's called Y arrangement of three resistance, or it can be any other element for that matter. So what I will do in this video, I will just write the conversation formula from delta to Y. So basically how we transform, if there is a delta arrangement given, how we transform it into a Y arrangement. So the values will change essentially. So let's say we have here R1, R2 and R3, and let's say we have here RA, RB. I'm just arbitrarily writing them. So we have this arrangement of resistances, and sometimes we will see for minimization purpose, when minimizing or finding equivalent resistance, basically sometimes Y arrangement is bit helpful. So we need to, in a circuit we may get a delta arrangement which we need to convert into a transform into a Y arrangement. So if we do that, if we have to do that, what we do, how we write the formula. So basically we have this one here, this is a delta, and this will be converted into a Y, which will have a resistance here, and a resistance here, like that. So this one is the first one, this one. When we write the formula for this one, let's call this one as RA maybe. So the value of this resistance will be, we have, this is the common node. Here we have two resistances connected, R1 and R2. We write them in the numerator as products, as they are in product. And in the denominator, it's just summation of all the three resistances, R1, R2 plus R3. So that is the value of R, like this one. Now if we want to write the formula for this one, when we say this one, let's call it RB maybe, and we can see that the resistance, this is going to this node, and the two resistance in the delta connection, which we are transforming into Y, the two resistances are R2 here and R3 here. So that will be R2 times R3 over R1 plus R2 plus R3. Finally we have, let's say the last one, this one, let's call it RC. We can see here the two resistances, this is going to this node, and the two resistances going to that node in the delta connection is R1 and R3. So R1 times R3 over R1 plus R2 plus R3. So instead of trying to remember the formula and whatever, if we just remember the pattern in which the formula comes, I mean in terms of A, B, 1, 2, doesn't matter actually. What the fact is that we have three here like that. I am summing it up again. So I have arrangement like this, and I need something like this. So when I want to find this one, it will be the product of this one and this one on the top, on the denominator, on the numerator, sorry. And the denominator will always be the same. It will be the sum of all three resistances. When this one will come, so the denominator is always the same. Let's call it delta or something. Sometimes we write like that. So in this case, if we do R1, R2, R3 thing, R1 plus R2 plus R3, it's always coming in the denominator, and RA is becoming the product of these two. This one is becoming the product of this one and this one, like that. So yeah, that's very simple, and this is just the Y and delta to Y transformation. I will do in the next one the Y to delta transformation. Sometimes we need that as well, so we need to know the formula.